I recently made a really simple example of machine learning that I think could help explain the concept to students aged around 11 plus, any students who are really familiar with a little bit of Python. The idea is that the students teach the computer to learn its number bonds to 10, which should be a maths concept that's really familiar to them. Learning which pairs of numbers make 10, like 3 and 7, 6 and 4, 8 and 2, and those sort of pairs, those bonds that are fundamental building blocks of maths. And we're going to teach the machine how to learn those numbers so that it can add them up. And we're going to do that by playing a little game. The computer stores what it thinks all the number bonds are in an array called bonds, and it starts off thinking that they're all 5 at the beginning, and we're going to train it gradually to learn the right answer. We're not going to tell it the correct answer straight away because I think that would be too quick, and I think students will be more invested in the exercise if they can see it learning slowly. So what happens is the computer generates some random numbers, and you have to give it the number bond. The machine gives its guess as well, and you kind of have a game and you play against each other. But if you get a correct answer, your answer will train the machine, and it does that by giving an average. So it takes what it thinks the answer is and averages that with the correct answer that you gave it. So it will slowly move towards getting the correct answer. And the reason I'm doing it slowly rather than doing it straight away is so that the students can see the data set improve and be a little bit more invested in the process rather than just seeing it, learning it straight away. It would be too quick and too easy. So we'll give it a go. I thought it would be fun to get this running on a microbit. You can run the previous version of this in another video. You can run that in any Python environment, but I thought it might be fun to put it on the BBC microbit. Also an opportunity for me to show off the serial console as well. So you can do lots of Python work with the microbit, not just using the microbit device itself, but using a serial console. So just go to the regular Python editor, connect your microbit by web USB, make sure you're using the Chrome or Edge web browser, and flash the program to your microbit like that, and then open the serial console, and you'll see the output of the program here, and we can use the keyboard on your computer to interact with your Python program that's running on the microbit. So it's a really simple way of getting a very nice Python environment running very quickly on a computer in a classroom. So here's the program. It's telling us we need to train the computer. It shows us the current data set. It's currently all at 5, and the random number that it's given us is 6, and the machine said that the number bond was 5, which is wrong. So we're going to train it. We're going to give it the right answer. So in order to get to 10 from 6, I need to add 4. So 4 is my answer. I've got the right answer. So I've scored 1, the machine has scored 0. The next random number is 1. The machine has got the wrong answer again. So what we'll do is we'll give it some correct answers and we'll train the machine. And you should see this set of data here gradually improve. You can see this answer here that we have for 6. It's gone from 4. It's gone from 5, thinking that was the right answer, to 4.5. So it's getting closer to the right answer. Hasn't quite reached it. So anyway, let's carry on, give it some more correct answers and see if that training set of data improves. So number is 0 this time. So 10 is the number bond to get to 10. And let's see what the next number is. It's 3. So I think we need 7. So you can see I'm beating the machine hands down here. Except the machine has already learnt one of its number bonds. The random number was 6. And it's already got the correct answer. So that's quite impressive. It's learning very gradually. So the machine's got one right. I'm going to carry on giving it correct answers, and we'll see if the playing field gets leveled up a bit. Right, so again, we've got 6 again, which the machine already knows. So it's got that one sorted out. It's got that one taped. Let's see what comes up next. It hasn't learned the number bond for 3. So we'll give it the correct answer and see if it gets a little bit closer. We've got 6 again. The machine's been quite lucky here because the machine knows that one. So I've got the correct answer. If I give it the wrong answer, if I deliberately give it the wrong answer, it says, wrong, are you trying to mislead a poor machine? And it will actually ignore that data. It might be interesting to modify the program so that it does actually take take notice of incorrect answers, because you could actually mislead the machine if you wanted to beat it. Give it some incorrect training data, and then what you can do is, when it's learnt some number bonds, is you can actually reset the scores. It will keep the same set of data, and you can play on a slightly more level playing field. So let's see now. It's learnt 6. Oh, I gave it the wrong answer there. I'm thinking 6. Right, but it hasn't got 9, so we'll give it the correct answer for 9. And we'll carry on playing. As you can see at the moment, because I made a mistake, the human, me, I've got 1 out of 3, and the machine's got 1 out of 3. So already we're on a more level playing field. So we'll give it a little bit more data and see if it learns any more answers. It's getting closer to knowing the bond for 0, but it hasn't quite got the correct answer yet. So you can see from the training set of data, it is getting closer. If you give it a few more answers, you should see over a period of time, it will learn all its number bonds. It only has to get close enough so that when the number's rounded, it will give you the right answer. And because we're printing it out as a floating point number, we can actually see precisely what the number is that's in its training data set each time. And you should see, as time goes by, the numbers should be bigger at the front of the data set, and they should be smaller at the end, and they're definitely getting that way. So it is beginning to learn. So I will put the code for this microbit version on my website, on the blog, so you can try that out on a microbit if you want. All you need is a microbit and a computer, and some internet to go to the standard Python editor, to go into the serial console. Or if you fancy trying out the new Alpha editor, if I disconnect this, the new Alpha editor for the BBC microbit, the Alpha Python editor, has got a serial console that will actually stay on the window at the same time as the program, and you can try it out on that as well. If I connect it again by web USB, just pair it up in the normal way, you can see the serial console is down in the bottom half of this window, and your program is at the top, which is quite nice because it enables you to see your program. You could even make changes to your program and flash it back to the microbit and see the output in the serial console at the same time in the same window, which is quite a nice feature because it will enable you to do debugging and all sorts of interaction with the microbit in a way that perhaps you hadn't thought of before. But it works in exactly the same way. I'm going to put some data in here. I'm just typing on the keyboard and interacting with the program in the very same way. If you've got any ideas for how you might adapt this idea for a sort of simple abstraction of machine learning for your students, or if you think you might find it helpful, or if you try it out in your class and your students have got some feedback on it, or make some alterations or improvements to this program, I'd love to hear about it. Please do get in touch with me either on Twitter or on YouTube.